All right, guys, let's knock out this test 9 review. Help you get ready for tomorrow. Number 1 says find the radian measure of 36 degrees. Remember, the quick way to go from degrees to radians is just take the degrees, divide it by 180, and we're also going to put a pi up there in my numerator. If you reduce that, 36 goes into 185 times, so you should get pi over 5, or 1/5 pi. Pi over 5 looks really good. And number 2, find the degree measure of 5 pi over 3. Remember, pi radians is the same thing as 180 degrees, so you can just substitute the 180 right there. 3 goes into 180 60 times. 5 times 60 is 300 degrees. So 1 and 2. Also, those are the short methods. I think we went over the long way in class today, so you should be fine there. Number 3, find one positive and one negative angle that is coterminal with 120 degrees and also negative 2 pi over 3. Now, the 120, I want your answers in degrees. The negative 2 pi over 3, I want your answer in radians. So coterminal, one positive. I'm just going to add 360 to 120. If you do 120 plus 360, it should give you 480. That's the positive one. And if you do 120 minus 360, I'm pretty sure that gives you negative 240. You might want to check me on that. I don't have my calculator with me. Negative 240. The negative 2 pi over 3, to get a positive one, I'm going to add 2 pi. And remember how we added 2 pi? When we added 2 pi and also subtract 2 pi. There we go. Take your denominator, which is 3, double it, which is 6. So 2 pi is really 6 pi over 3. So what I'm going to be doing is I'm going to be adding and subtracting 6 pi over 3. If I add 6 pi over 3 to that numerator, I'm going to get 4 pi over 3 because negative 2 plus 6. If I subtract it, negative 2 minus 6 is negative 8 pi over 3. And there's your 4 answers for number 3. Number 4, find the length of an arc that subtends a center angle of 45 degrees and a circle radius 12. Here's your big formula for all these kind of problems in radians. Theta, it's supposed to be theta, is the arc length over the radius. And they're asking us here for the arc length. Now remember, this is radians. So when they gave me 45 degrees, I already knew I'm going to have to change that into radians. And if you change that to radians, it's really pi over 4. And that's going to equal S over R. I do not know what S is, so I'm going to leave the S. R is 12. And because I have a fraction on each side, I'm going to cross multiply. 12 times pi is really 4s. If you divide by 4, you get 3 pi. And it should be 3 pi meters, by the way. So 3 pi meters. And that's all you can do in that one. Number 5, find the exact values of the 6 trig ratios of that triangle. So I have 7 and 8. I need the third side, so I'm going to do 7 squared plus who knows what, b squared is 8 squared. 8 squared, by the way, is 64. And if I move that 7 squared over 40, that is 49. 64 minus 49 is 15. So the side over here is going to be the square root of 15, because you would take the square root of both sides right here and you get square root of 15. All right, now, so here we go. Sine theta. Sine is opposite over hypotenuse. That's just going to be 7/8. And if it's 7/8, that means cosecant, sorry about my marker here, cosecant theta is 8/7. Cosine theta is adjacent over hypotenuse, so that's the square root of 15 over 8, which means secant theta would be 8 over square root of 15. But don't forget, you need to rationalize that. You move the square root to the numerator, take the number out on the bottom. Tangent, 2 ways you can do tangent. One is you can look at the triangle, and you can do opposite over adjacent, which would be 7 over square root of 15. You can also look at your first 2 answers. Tangent's always sine over cosine. The 8's would cancel, I'd give you the same thing. You do need to rationalize that. Take the 15 up to the numerator, pull it out on the denominator, and your last answer is cotangent. Cotangent, I'm just going to flip this one. Remember, when you do reciprocal of tangent, do the easy one. So I'm going to do the first answer right there, because doing reciprocal of that second one would be pretty darn tough. Okay, so there's the first 5. 6 and 7 say solve the triangle. Okay, that means we're going to find everything that's missing in both of them. So first thing I notice is, let me make this a little bit bigger. First thing I notice is that angle is 52 degrees, which leaves a total of 38. So there's the first answer. Those two, all 3 angles have to add up to be 180, which means the 2 smaller angles have to add up to be 90. So lots of ways you can go here. I'm going to go tangent. Let's go tangent first. Tangent of 38 degrees is opposite over adjacent, which I don't know, so I'm going to put X there. I'm looking for actually this side right here, in case you're curious. And then to find that answer, I'm just going to do 35, divide divided by tangent 38. Remember, always divide. If x is your denominator, you're going to divide by the trig function. All right, when I punch that in, I'm getting 44.8 if I round to one decimal place. So I'm going with 44.8 right there. And all I'm missing is the hypotenuse. And you got all kinds of choices to do hypotenuse. Since I used 38 the first time, I'll just use it again. I'm going to say sine 38 degrees is opposite over hypotenuse. And again, I don't know what the hypotenuse is. I'm trying to find it now. So same deal. I'm going to say, okay, 35 divided by sine 38. That's an 8, by the way, right there. 35 divided by sine 38. Let me punch that in. When I punch that in, I'm getting 56.8 right there, 56.8, which makes sense. This is the biggest. It should be the biggest side since it's the hypotenuse. It is. We're good, so. Let's look at number 7. Number 7, this is in radians. Okay, so that's 3 pi over 8. Now in radians, think about this. All 3 angles in degrees add up to be 180. 180 in radians is pi, so all 3 angles here have to add up to be pi. So the 90-degree angle is pi over 2. Is pi over 2, which because this is already 3 pi over 8, pi over 2 is really 4 pi over 8. So those 2 angles together give me 7 pi over 8, which means this angle down here has to be 1 pi over 8. So there's the angle. And this time I know the hypotenuse. I don't know either the other side. So I'm going to go, first I'm going to go sine of pi over 8 equals x over hypotenuse. So I'm basically saying this side right here is side x. I'm going to figure out what that is. So this time, because the 425 is in my denominator, I'm going to multiply 425 times sine pi over 8. Now, when you do this, you need to make sure your calculator's in radians, not degrees, because obviously the angle's in radians. So I'm going to punch that in real quick. And when I punch that in, I'm getting like 162.6. So that was the side, 162.6, which to be honest, that should be the smallest side because it's opposite the smallest angle. Okay, so that's supposed to, I'm having a hard time, 162.6. Now to find the other side, I'm going to use the pi over 8 again. And this isn't the only way to do it. You could use sine of 3 pi over 8 if you want to. You could do tangent if you want to. Just, choices are yours. So I'm going to do y over 425 this time. So I'm going to find the adjacent side. So right now I'm looking for this side. I'm going to work it the same way. I'm going to do 425 times cosine of pi over 8. I'm going to punch that in. And when I punch that in, I'm getting 392.6. So that'll be right here, 392.6. So there's my 2 sides. There's my missing angle. All there is to it. Number 8 and 9. Sketch a triangle that has acute angle theta and find the other 5 trig ratios. Okay, this one says sine of theta is 8/17. Okay, so I'm going to draw my triangle. Again, I'm kind of apologizing for this. I don't have my pencil with me. I just have a kind of an old stylus, so it is what it is. Sine is opposite of our hypotenuse, so I'm going to 8/17. If you do Pythagorean theorem, you're going to get 15. I'm going to shorten it to keep the video shorter. I got the 15 because I did a squared plus b squared is c squared, and I got 15. So first thing I know is the cosecant is reciprocal of sine, so it's just 17 over 8. Cosine is adjacent over hypotenuse, which is 15 over 17, which means my secant is reciprocal of that, which is 17 over 15. Tangent is opposite over adjacent, and then cotangent is reciprocal of that, or adjacent over opposite. Trying one more. Same thing. Cotangent is square root of 3. Now, here's what I would do on this one. Go ahead and draw your triangle, but I'm going to wait and fill it in. Let's think about it this way. Tangent is opposite over adjacent, which means cotangent is adjacent over opposite. That's really square root of 3 over 1. So I'm going to do adjacent over opposite right there. And to find the hypotenuse, I'm doing a squared plus b squared is c squared. So I'm going to do 1 squared, which is 1, plus square root of 3 squared, which is 3, equals c squared. If I add those up, I'm getting 4 is c squared. So c is going to be 2. So there's my hypotenuse. By the way, that sure looks like a 30, 60, 90 to me. So tangent is reciprocal of cotangent. So it'd be 1 over square root of 3. If you rationalize, take the radical to the top, take the number on the bottom. Sine theta, opposite over adjacent. I'm getting, opposite over hypotenuse, 1/2, which means my cosecant is reciprocal of that, which is just 2. And my cosine theta, adjacent over hypotenuse, which means my secant is going to be the reciprocal of that, which would be 2 over square root of 3. Again, one more time, take the radical to the top, take it out on the bottom, and there you go. Then we get to the review stuff. Number 10. Number 10 says find the inverse of that function. So remember inverse, take the x and y's and switch them. So I'm going to put the x over here, put the y's where the x's were, and your job is to get, now you got to get the y by itself. So first step right here, I'm going to cross multiply. So it'll be xy plus 2x. Cross multiply 1 times y, 1 times 2. Now I have two y's, and that's a little bit tougher to get them by itself. But what you're going to have to do here is get the y's together first. So I'm going to switch places. I'm going to put the y over here with the xy. I'm going to move the 2x over there with the 2, like that. Now, if there's a trick to the problem, here it is. To get 2 y's into 1 y, you have to factor out the y. That will leave x minus 1. Over here, I still have the same thing. And then to finish up, to get, because it says y times the parentheses, the opposite of times is divide. So I'm going to divide both sides by that x minus 1. So my final answer, and don't forget, we write it like this. We put the inverse of f of x is going to be negative 2x minus 2 over x minus 1. And there's the inverse. I think that's all I got here. Yep. 11, another inverse. Okay, so same deal. Take your x's and y's and switch them. So the x is coming over here, the y is coming over here. And now you got to get the y by itself. So the first thing I got to do is I got to take the cube root. So if you take the cube root of x, do not put a plus or minus in the front. If it was an even root, I would put a plus or minus in the front. And then just move the 4 over to the other side. And that's all it's going to take. So when you move that over, I'm going to go ahead and change the y to inverse of f of x. And that's going to equal the cube root of x. That's supposed to be a cube root. Sorry, cube root. Come on now. There we go, kind of. Plus 4. All right, and there you go. Or, of course, you could put 4 plus cube root of x. Either way. All right, number 12. A couple more here. Number 12. Find the average rate of change between that x and that x for that function right there. So remember how we do rate of change. We're going to put it's f of x. Yeah, so I'm going to go f of x. I should be saying, I'm trying here. Come on now. I'm going to go f of 3 minus h minus f of 3. And that's going to be over the x's, which are 3 minus h and 3. Okay, so to find f of 3 minus h, I'm going to plug 3 minus h in here. In that function, square, multiply double square. If I square to 3, it's 9. Multiply together double. Square the h, which is h squared. Then you got to take the 2 through. So I'm going to take the 2 through, and I'm going to go ahead and bring it over here. 2 times 9 is 18. 2 times 6 is 12h. 2 times h squared is 2h squared. Minus f of 3. So I'm going to take that 3 and plug it in right there. If I plug that 3 in there, I get 2 times 3 squared, which is 2 times 9, which is 18. So it's going to be minus 18 over, look at my denominator, 3 minus h minus 3. The 3's cancel. This gives me negative h. So I'm going to look at the numerator now. 18's cancel. And that leaves me negative 12h plus 2h squared over negative h. So what I'm going to do is I'm going to divide that negative h. Because all 3 terms have h's, I'm going to cancel, but I'm going to cancel with a negative. So negative h goes into negative 12h, just makes it positive 12. And then negative h goes into 2h squared. I'm going to make that a minus because it's positive divided by negative, and a 2h. And there we go. As far as you can go on that one. All right, last one, 13. Piecewise, your favorite thing to graph. Mine too. I think it's everybody's. Take the negative 4 first and plug it in there. If I plug negative 4 in there, because it's negative, it'd be negative 4, which is positive 4. So I'm going to go negative 4, positive 4, empty circle, right? Come on now, right here. And then because it says go left, I'm going to plug in negative 5. If I plug in negative 5, I get positive 5, which is here. So the line's going to do this, going, come on now, connect. I'm sorry about this. I don't know what's happening with my iPad. All right, so connect the dots. La, la, there we go. Come on. Come on. Again, sorry about this. I'm not sure what's happening. Okay, there we go. And then this one, guys, I'm telling you, when they give you 2 numbers like that, that's the best of all worlds because it tells you where to start and where to stop, and it's a line. So if you plug negative 4 in there, you get negative 1. No matter what you plug in there, you get negative 1. So I'm going to go to negative 4, negative 1. It's a filled-in circle this time. Also going to plug the 2 in. That's where I'm stopping. And also get negative 1, 2, negative 1, except this time it's an empty circle. I'm going to connect those. It's a horizontal line, obviously, because there's no x. It's just -1. And the last part here, I'm going to take the 2, plug it in. It'd be -2 plus 4, which is +2. So if I plug in +2, I got +2. That's a filled in circle. And because it says go to the right, it says greater than, I'm going to plug in 3. If I plug in 3, I get -3 plus 4, which is 1, which is right there. And because it's a line, that's all I need. I'm going to connect those dots. La, la, la. There we go. And that's it. That's your graph. Piecewise. All right, hope that helps you a little bit. Hope you get to use this a lot. Get ready for a good start for the second quarter. And can't wait to see you tomorrow. Come see me if you need me.